Okay, here we go. We're going to do a tuning fork lab in class, and it would help if you had some pre-knowledge so that when you walk in the door, you can just get going on collecting data and working through the lab. So I want to kind of give you a heads up on some things. You can take a few notes, but the key is that you understand kind of what you're doing versus copying down a bunch of processes. All right, so the first goal. We're going to find the equation of a sound wave created by a tuning fork. So this is what we were doing in 4.4 part 2. I'm going to give you a graph of a sine wave, and you have to write the equation for it. The difference is that when we do it in class on a worksheet, the numbers are really pretty. They match up with the unit circle. And as much as that is a good way to start learning a process, to use some nice easy numbers, we find that in real life, numbers don't come out super pretty like that. So here's an example. It's a sound wave. That's just a beautiful sine wave. We could either create our own sound wave by humming or something, but we'll try to keep a better sine wave and use like a tuning fork that's actually in tune. And we have equipment that will collect that sound wave and graph it onto our calculator. And then we're going to come up with an equation. When we collect that data from that sound wave, it's really just a whole bunch of ordered pairs that get plotted. And then they connect them so it looks like a wave. Our goal, so that's going to be in your stat plot. And then our goal is to write the equation, and we're going to put it in y equals. And in a perfect world, our equation graphs right on top of the scatter plot sound wave that we collected. That's goal 1. Goal 2 would be then we would try to create our own musical instrument that would make that very same sound wave. We probably aren't going to get to goal 2. We're going to probably stick with goal 1. All right, let's get going. All right, so here's what it is. Now, I've got a nice little graph here, and this is actually not a terrible graph. It actually fits nicely. You can see my scale is pretty decent here. When we do this, our numbers are going to be very, very, very small. So everything's going to be a tiny decimal value, and it won't even be this nice. And it certainly won't match up with things on our unit circle. All right, so let's just understand what you are doing when you're looking at this graph and you're trying to come up with the A, B, C, and D for your equation. You have to look at the graph and determine your amplitude, your period, your phase shift, vertical displacement. Take those values, turn them into an A, B, C, D. Now, how do we find those values? How do you find the amplitude? All right, so I think what we've got to do is we got to understand there's like 2 scenarios here. There are going to be times where you're looking for a distance. And if you're looking for a distance between 2 items, and let me talk a little bit about this graph and what you're going to see. Like I said, it's going to be a scatter plot, and it's going to be like just a bajillion little points, all the way around here. Now, if you're looking for a specific point on that graph, you're going to be hard-pressed to come up with it, because if you're going to trace this, it's probably going to bounce around quite a bit. And the only points that we can really count on getting are the maximums and the minimums. These ordered pairs, as we trace our graph, we can actually truly get what those ordered pairs are. So everything we do will be based off of these. All right, got it. So now, sometimes you're going to be looking for the distance between the ordered pairs. Now, depending on which feature it is that you're looking for, sometimes you're looking at kind of something that's going on horizontally, and so you're going to be looking at X values. Sometimes you're going to be working with a feature that is a vertical kind of thing, and so then you're going to be looking at the Y values. So I might grab, I don't know, this ordered pair and this ordered pair, and if I want to find the distance between them, well, that's a horizontal thing, so I'd be looking at the X values for each of those. We could go trace it. We would have an ordered pair, we'd have an ordered pair, and we could look at the X values on those ordered pairs. If I wanted to find the distance between those, any idea what I would do with those to find the distance between them? answering the ed puzzle. Okay, just make up some fake numbers here. What if, I don't know, this x value, let's just say, if this x value was a, well, I don't know, let's look at it. It looks like it's about a 1.3, let's say. And then there's some y value. This x value looks like it's about a 3, I'm just going to go 3, and then there's some y value. If I want to know the distance between those, hopefully you said that, oh, well, I would just subtract those x's, and that would tell me the distance between them. So anytime you're doing a distance, you would subtract. You always take your bigger number, subtract your smaller number. All right. If I wanted to do something vertically and find a distance, so maybe I have this ordered pair down here. If I'm doing something vertically, I would look at the y value, whatever this y value and whatever this y value is, and I would subtract those y values. That's how I find the distance between them. All right, that's one scenario. The other scenario would be to find the middle of something. Typically, when we are writing our equations, there's going to be a scenario where we have to find the middle of it. Perhaps the middle between this spot here and this spot here. If I want to find the middle, it's ultimately finding the midpoint. Now, typically we would only be looking at either the x or the y there to find the middle of that. And so if I was doing something that dealt with horizontal, then I'd find the midpoint of the x's. If I was interested in the y value, then I'd find the midpoint of the y's. So let's talk about how do you find a midpoint. Do you remember our formula? This would have been like in chapter P. How do you find the midpoint? Okay. Ultimately, you're finding an average. You're adding two values and dividing by 2. So if I was doing something horizontal, I'd add the x's and divide by 2. If I was doing something vertical, I'd add the y's and divide by 2. So anytime you're looking for a midpoint, you're going to add, then divide by 2. And that'll find the average or the middle for you. Okay, there you go. Now let's look at each one of these scenarios specifically and see if you can figure out, is it an X type of situation or is it a Y type of situation? That's your first question. And then are you looking for the distance or are you looking for the midpoint? All right, let's start with amplitude. Okay, let's get rid of some stuff. Okay, remembering that I'm basing everything off of peaks and valleys. Those are the only points that I'm sure that I'm going to be able to grab. All right, amplitude. First question to you in the ed puzzle. Is amplitude something that is a vertical thing that you're interested in Y values, or is it a horizontal thing where you're interested in X values? All right. Amplitude is definitely something, it's called vertical stretch. And so yes, definitely a vertical thing where you're using Y values. The amplitude, if you will recall, is by definition half the distance between the min and the max. How perfect is that? So obviously then we're going to be doing the distance scenario, not the midpoint scenario. I want half the distance between the min and the max. So what I'm going to do is I'm going to find the minimum, and I'm going to find that ordered pair, and I'm going to find the maximum and find that ordered pair. And I need to find that distance. All right? In the ed puzzle, which method would you use to find the distance between those for our amplitude? Okay, we already discussed it's a vertical thing. You should be dealing with Y's, not X's. And if it's the distance, then I should be subtracting those. So you would take your higher Y value and subtract your lower Y value and see what that distance is. Now, the definition of the amplitude, though, says it's half that distance. So you'd want to divide it by 2 after you found that distance. Okay, so just to kind of bring it back, what are we doing? You're going to have a sound wave. This wave that I have an example of is on your calculator. You're going to trace it. You're going to find some ordered pairs. And then like we just said, to determine your amplitude, you're going to find that distance, take half of it, boom, got the amplitude, which is ultimately your A value. All right, let's move on. Let's talk about the period. in the ed puzzle, is the period something that's horizontal, that's your X, or is it something vertical that deals with your Y's? Okay, period is how much space it takes to make one wave, and that's a horizontal thing. How long before it starts to repeat? So you're going to be dealing with X's on your period. Okay, so now the period is how much space it takes to make one wave. All right, so what do you think? Is that a distance or is that a midpoint question? All right, should be distance. How much space does it take? I need to know the distance. Now, we've talked about how a sine wave ultimately looks like this. And then to get from here to here is one period. But really, this is a periodic function. It keeps repeating, it keeps repeating. And so that space that it takes to get from the middle to the middle really is the same as the space that it would take to get from a peak to a peak, which is the same as the space it would take to get from a minimum to a minimum. It doesn't matter. As long as you pick two matching points, that distance there is the same. And that distance is your period. Now, because I can't deal with these spots in the middle, because I'm only guaranteed to be able to get peaks and valleys, I'm going to go, I don't know, I guess I'll choose the peak to peak versus the valley to valley. Let's go peak to peak. So I want to know this distance from peak to peak. I could pick any set of peaks. It doesn't matter. Peak to peak. I'm looking for that distance. Okay, so in the ed puzzle, what are we going to do with this point, let's say, and this point here? All right, distance, I should be subtracting. I'm going to subtract those. Period has to do with the X values, so I should be subtracting the X's. And that's going to give me that distance, which is my period. Now keep in mind that the period is not the B value, but that there is a definite relationship between those. We'll come back and look at an example. All right, phase shift. Phase shift in the ed puzzle, vertical or horizontal situation. I guess the question is, are you dealing with X's or are you dealing with Y's? Okay, phase shift is an X deal. Phase shift is how far it shifted over from where it's supposed to start. A sine wave is supposed to start at 0 and head up. So the question is, where is the first place on this graph that you're at 0 and you're headed up? Well, kind of the problem that we have, I guess, is it's when your sound wave is going to start randomly whenever the equipment starts collecting data. So you got to come across it. I don't know. I'm about right here at 0 headed up, somewhere in there. So let me throw a dot there. I'm thinking it's somewhere right here-ish. I'm at 0 headed up. I need that spot right there. Now, would I want that X value or do I want that Y value for the phase shift? Okay, I want that X value because phase shift is an X kind of scenario. It's your C value that shows your horizontal shift. To get this X value, the problem that I have is that my graph will probably, if I were to sit here and trace and trace and trace and trace and trace, odds are it's going to hop over the spot I want and it's going to go like from there to there and I'm not going to be able to get that right there. And so I have to find this X value from this valley and this peak. Now, wouldn't this be in the middle of the valley and the peak? Okay, so here's one where I'm going to be using the midpoint. Now, not only is this point, it's easy to see that it's in the middle vertically, but it also would be in the middle horizontally between this point and this point. So I'm going to find the midpoint between the two X's here. And it should hopefully be this value right here. And then that would be the phase shift, whatever that X value is. All right, last one, vertical displacement. X value or Y value? All right, it should be a Y value. It says vertical displacement. That's a Y value. The vertical displacement is the place, it's like the equilibrium. I like to call it the equilibrium. It's right where your graph right where the middle of your graph. So somewhere in here, like I'm kind of messing that up. That's just, it's an equilibrium line. And that equilibrium line is normally on the x-axis. But in this case, it got shifted up. So the question is, how far did that equilibrium move up? Well, it's the equilibrium because it's through the middle of the graph. And so to find out how far it went up, I need to find this spot right here to see where it moved up. But I'm going to find the y value of that. So if you think about this, if I want to find the y value of that point, what do you think I need to do? Answering the Ed puzzle. All right, we're going to be looking for the middle. We want the midpoint of that, but we're going to find the midpoint of the y's. So I'll add the y values, divide by 2. Boom, that's going to be my vertical displacement, which is my d value. All right, there it is. All right, I'm moving pretty quickly through this. My first video was like 35 minutes. I'm trying to be shorter. Okay, so I'm moving fast. I don't want it to take that long, but I do want it to recap one more time. Let's go through big picture. It's the same graph. Let's actually go through the motions. Let's write the equation that would graph on top of this. We'll pretend this is a scatter plot that was given to us that we got. Okay, let's start with A. A is your amplitude. Amplitude is half the distance between the min and the max. So I'm going to go with this point and this point. I need to know that ordered pair. I'm going to make it up. I don't know. I'm going to call it 1.6. And it looks like I went down 1. What do you think? Maybe like a 1.4? Or I'm sorry. This down here is just a 0.6. Sorry. 0.6. Did you catch that? That didn't seem right. 0.6. This one's more like a 1.4, I think. And then I'm up 5. Now, obviously on your lab, you're going to have way uglier numbers, but I thought I could play with some decent numbers for this. All right, so I want to know half that distance to find my amplitude. So I'm going to, it's a y value thing. It's a vertical. So I'm going to find the distance. So I'm going to take 5 and subtract the -1. 5 minus -1. But I want half the distance for the amplitude, so I divide it by 2. Looks like that's going to come out nice to a 3. So that means my amplitude is 3, so then I get to plug into my equation 3 for the A value. Does that make sense? Okie doke. Let's look at the B value. Still knowing that I have these 2 points or any other peak and valley, remember that B affects the period. So I'm looking at the period that it takes, the length of space that it takes to make one wave. Do I have all the points I need here? Nope. I need this next peak. I need to go peak to peak right here. So that point, oh, I wish I wouldn't have, I don't know. It looks like it's about a 3. I'll just keep life simple. It's like a 3.5 right there. All right. I want to know that distance. I'm looking at the x value of that distance. What does that distance appear to be? All right. I think you're just going to take your 3 and you're going to subtract your 1.4 and you're left with a 1.6. So that means that the period is 1.6. Is that your B value then? Nope, that is not your B value. You need, the period and the B are not the same thing. You've got to use your formula. The period is equal to 2 pi over B. So you're going to set up a little equation and put the 1.6 in for the period. Go solve for that. See what B equals. All right, you should have somewhere like 3.29 or something, or is it 9.2? I forget now. I just asked Google what it was and I forget. I think she said 3.92. I might be wrong. Hang on, I gotta be right. Okay, it was right, 3.92. I didn't have a calculator, so I just asked Google. Okay, all right, next question. C. C is your phase shift. All right, now I have 3 points that I have all their ordered pairs. What would you do you think, to find the phase shift? All right, I'm going to help you. Right here is the first spot where it's at 0 headed up. I'm looking for that spot. Okay, so that should help you. Now answering the ed puzzle, what should I do to find the C? All right, I'm looking for the middle, so I'm going to do the midpoint thing. And so I'm going to add them and divide by 2. The phase shift is a horizontal thing, so I should be adding the x's and dividing by 2. So I'm going to take 1.4 and I'm going to add the 0.6, and then I'm going to divide by 2. I'm dealing with the x's. How nice did that work out? That's 2 divided by 2. Okay, phase shift, or the C value then, would be 1. Now I am moving to the right, so when I write my equation, I would put a -1 there. Okay, last thing, and you're not having to write this all down. I'm just kind of wanting to talk through it with you, and then you'll be with a group and be able to talk it through with them. Last one, the D value, that's the vertical displacement. The vertical displacement is the equilibrium. In the ed puzzle, how are you going to find the equilibrium? Okay, it's the middle of the graph, so we're doing midpoint, but it's a vertical thing, so now I'm dealing with the y's. So I'm going to add the y's, 5 plus -1. That'd be a 4. Divide by 2. So the vertical displacement would be 2. And then I would take all these numbers right here and I would plug them in over there. I'm going to type it in my y equals, and I'm going to be amazed when it graphs right on. No, I'm not going to be amazed. I'm going to expect it to graph right on top. But it might take a couple tries. All right. Thanks for watching. Come in ready to go tomorrow. I want to get you going quick. Thanks.